Good day. I'm Maile Matsiba, my name. I hope all is well with you guys. Welcome to this wonderful channel. We're going to be looking at much of university engineering modules. Yeah. Today I'm going to be presenting a portion of the study guide, the 2017 study guide of a first chemical engineering module at the University of Pretoria. It's called CIR 113. It's actually chemical engineering 1. So we're going to be using the 2017 study guide. In this study guide, or in this module, the first section deals with dimensions, units, and also their conversions. Yeah. Um, Going straight to the study guide, I just want to look at an example in the study guide. The very first example of the study guide is based on conversion. It's actually example 1.1 of the 1.1 example 1.1 of the same 2017 study guide. The question says the viscosity of a liquid is 1 poise. What is the viscosity in pound mass per feet hour? And also it's what is the viscosity of what is the viscosity in pound mass per feet hour and also in Newton second per meter squared. Now, when you see the approach they used in the study guide, it's a little bit more complicated, especially for a first year chemical engineering student. Not only first year, but the very first question in the study guide. So when you look at it, it seems very complicated. I remember in my time when I look at this, it looked like rocket science, like it looks like something that fell from the back of the moon, like something far-fetched. You see, firstly, I didn't know what was a poise. You see, I had very little understanding about what is viscosity. So now, looking at all this, that in the only one table they were able to reach this answer, it proved very complicated. Like there were a whole lot of numbers there that I didn't know where they were from. So, but it's correct in itself, you see. And also the approach they use to actually convert it to Newton second per meter squared. You could see here that it's very short and straightforward. And then they got the answer here of 0.1 Newton second per meter squared. Now, in as much as this is correct, I want to highlight that we're not going to be using this approach in this course. We're going to always make sure that we use the step-by-step approach. In as much as this method is correct, but it shows there's a whole lot of blind spots. Like you only see how they got it, but you don't really know what they did. So in the approach we're going to be using, we're going to make sure that we do a step-by-step approach of every question that we're going to be doing. So I want us to redo the same question, but use a step-by-step approach. So it's going to be a little bit longer, but it's really worth it at the end. Not only will we know that the answer is 241.9 pound mass per feet hour, but we'll also understand why is it that. So yeah, let's go. Let's redo the question. Now this is it here. This is the page that I have here. Yeah, the viscosity of a liquid is 1 poise. What is the viscosity in pound mass per feet hour? Now what we need to first look at is, well, what do we know? We know that 1 poise is equals to 1 gram per centimeter second. Now, this is something that is given. You don't need to calculate this. Let me just put the grams properly. This is something that is given, and this is something that is known. 1 poise is equals to 1 gram per centimeter second. Now, we have to first convert it to pound mass per feet hour, and also Newton second per meter squared. Now, looking at the very first one, we can see that it's mass and mass, and it's length and length, and then it's time and time. So this one is much more easier because you can actually convert grams to pound mass, and then convert centimeters to feet, and then convert seconds to hours. So we'll do the first step. Step 1. Convert grams into pound mass. So we take the same Poise, we say 1 gram per centimeter second multiplied by 1 pound over 453.6 grams. It's important. I want to highlight here that 1 pound mass is equals to 453.6 grams. Now, when you look at this, you realize that well, it's something very straightforward because this is something that is known. So what we can do out of here, after this is we can all just cancel the grams, and then we're left with. I just want to keep the one. I just want to keep it as it is so that it can be easy for one to be able to follow it. The grams are gone. This is what we have. Now this is our step one. You see? Now the second step is we can convert feet, rather can convert centimeters to feet. So let's say step 2, convert centimeters into feet. And we take the whole answer all over. It's important to understand that you can actually simplify this, but I just kept it this so that from the beginning to the end you can actually see what I actually did. So if we have this, now we need to convert the centimeters into feet, right? So we say 2.54 centimeters all over 1 inch, right? Now it might look like it's complicated, but it's not. But why did we put 2.54 centimeters into each? Let me just highlight here that 1 inch is equal to 2.54 centimeters. So why did we convert centimeters into inches, but we're saying we're converting centimeters into feet? Yeah, it's easier to feet. Well, 12. I'm trying and simplify it. Let me put it this way. It's easier to convert centimeters to inch and then from inch to feet. So instead of going straight from centimeters to feet, I decided that it's easier to convert centimeters into inches because we have an easy ratio here. 1 inch equals to 2.54 centimeters. And also here, if you can look at this, it's something that is given. So after we have this, then inch and feet have a very close relationship also. So let me do this. So this means we're going to cancel the centimeters. So we have second multiplied by 1 pound mass all over 453.6 multiplied by 2.54 all over 1 inch. So this is what we have now. But we need to convert. Our step 2 says we're converting centimeters into feet. But it's now that we have the inches, we can actually easily convert the inches into feet. So we then say 1 over second multiplied by 1 pound mass over 453.6 multiplied by 254 all over 1 inch multiplied by, now 1 feet equals to 12 inches. So we can always say 12 inch all over 1 feet, right? And I just want to highlight here that 1 feet equals to 12 inch. Now when we reach here, we know that now we can actually get rid of the inch then this is what we have, equals to 1 over second. I would like to keep it as it is, so that it can very easily be followed, and I'll simplify it right at the end. Now here we're left with 12 over 1 feet, right? So this is what we have now. So we can see now here that we have pound mass, we have feet, but now we have seconds. So this takes us to our third step. Step 3. Step 3. Convert seconds into hours. If we look at our problem here, we realize that we have converted what, the grams into pound mass, the centimeters into feet, and we left with the second. So we also still take the whole sum, like we still take the whole. Again, I have to emphasize that you can always simplify this and have one number, but I decided to keep it like this so that it can easily be followed. So let's go now. We have 1 over second multiplied by 1 pound mass over 453.6 multiplied by 2.54 all over 1 multiplied by 12 all over 1 feet. Now we need to make sure that we get rid of the seconds and into hours, so we can always say that it's 3,600 seconds all over 1 hour. So with that said, you can always cancel this, and this is what we left with. We left with 1 over 1 multiplied by 1 pound mass over 453.6 multiplied by 2.54 all over 1 multiplied by 12 over 1 feet. Excuse my handwriting again, all over 3,600 all over 1 hour. Remember the second is gone. Well, also let me highlight here that 1 hour equals to 3,600 seconds. Yeah. Now this is it. If you use a calculator here, you're going to easily arrive at equals to 241.9 pound mass per feet hour. That is the final answer. And yeah, if you reach here, then you got it right. That's what it is. So this is actually the approach I wanted to use. You could see that it's long. It's actually almost a page and a half, but it was worth it because at least you can follow what has been done in this process. As compared to this, in as much as this is right, well, later in the future one can be able to do it this way, but at least the purpose of this tutorial is that to give you the light behind what has not been said, what has not been explained in this section. So yeah, thank you, and then in our next video I'll make sure that I do the second conversion, which is converting it to Newton seconds per meter squared. So yeah, stay blessed.